Okay, Algebra 2. This is the rational zero theorem. This theorem is not extremely difficult. It is, however, kind of tedious, kind of long. Basically, we can use the rational zeros theorem to find all of the rational zeros of a polynomial. Now keep in mind that a rational versus an irrational number. An irrational number is going to be like a square root that you can't reduce. Okay? The first thing you want to do is arrange the polynomial in descending order based on its exponent. Then you write down all of the factors of the constant term. This should be the number at the end. These are going to be your possible values for p. Then you write down all the factors of the leading coefficient. This is the number in front of the largest exponent part of the problem. These are all of the possible values of q. So then we're going to list all possible values of p over q and of negative p over q. You do not have to rewrite it if it's a duplicate. You then use synthetic division to determine if each of those possible values is going to be a rational root. The way you know it is if you use synthetic division and you get a 0, then you know that it is indeed a root. So, looking at the first example, all we're doing is finding the possible ones. We're not actually going to go through and work it out all the way out. So, you want to start by looking at your constant. Your constant's the number at the end, and so that's 9. Okay? You want to list the factors of 9. 1 times 9 and 3 times 3. Then you look at your leading coefficient. That was 2. That's the number in front of the largest degree. Factors of 2 are 1 and 2. So then when you do p over q, keep in mind that it could be positive or negative combinations. So the way it works is you could have positive or negative 1 over 1, which is 1, plus or minus 1 over 2, plus or minus 9 over 1, which is 9, plus or minus 9 over 2, plus or minus 3 over 1, which is 3, plus or minus 3 over 2. I took each one of these and wrote it over each one of these. Those are your possible rational zeros. They're not all going to work. Okay, so for this first problem, that's as far as we have to go. So looking at the next one and doing the same thing, you start by figuring out what is your constant, and that is going to be 10. So the factors of 10 are 1 and 10, 2 and 5. Figure out what your leading coefficient is. In this instance, it's 3. Factors of 3 are 1 and 3. So p over q, which means your possible rational zeros, will be plus or minus 1 over 1, which is 1, plus or minus 1 over 3, plus or minus 10 over 1, which is 10, plus or minus 10 over 3, plus or minus 2 over 1, which is 2, plus or minus 2/3, plus or minus 5 over 1, which is 5, and plus or minus 5 over 3. And you're done with that problem. Go to the next page. I'm easing you into it. I'm just helping you figure out how to find what p over q is. Okay, one more, doing the same thing. So your constant is 20. So we have 1 and 20, 2 and 10, 4 and 5. Your leading coefficient is 1, so the factors are 1 and 1. So basically, to get your p over q, you have plus or minus 1 over 1, which is 1, plus or minus 20, plus or minus 2, plus or minus 10, plus or minus 4, and plus or minus 5. And the reason it's just the numbers from up here is that when you put them over 1, it just is that number. All right, one more. So our constant is 49. So this is actually going to be your p, which goes on top. Anyway, we have 1 and 49, 7 and 7. Your leading coefficient is 1, so you have 1. So P over Q is plus or minus 1, plus or minus 49, plus or minus 7. Remember as we get to the next one that if you have repeats, you do not write them. So our constant is 12, and so we have 1 and 12, 2 and 6, 3 and 4. Our leading coefficient is 3, so we have 1 and 3. So P over Q could be plus or minus 1, plus or minus 1/3, plus or minus 12, plus or minus 12 over 3, which is 4, plus or minus 2, plus or minus 2/3, plus or minus 6, plus or minus 6 over 3, which is 2, which is already written, so I don't do it again, plus or minus 3, plus or minus 3 over 3, which is 1, already written, don't do it again, plus or minus 4, already written, plus or minus 4 over 3. All right, going to the next page. Now you've got to go the rest of the way through the problem. You've figured out how to tell what rational zeros would be, but now you got to figure out which ones actually are. So the same thing we did. You found our factors of the constant, you found your leading coefficient, you made your list, you use synthetic division and just test them out. My suggestion is to start by testing the whole numbers. And if, when you do this, your remainder, okay, your last number here is not 0, then it is not a 0. If it is 0, then it is a 0. So this right here would be one of my zeros. This right here would be one of my zeros. Not a 0. This one is a 0. So the rational roots are 3, 1/2, and -1. And they're saying -3 also. They don't show that one, but if you did synthetic division, then you would see that it was a 0 for the remainder. All right, last page of your notes. So they want us to find all the zeros of this function. So start by figuring out your constant is 60. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Your coefficient, your leading coefficient is 1. So your possibilities are a positive or a negative of all of those numbers, okay? P over Q could be positive, negative, 1. If you want to write it the same order, you want to not rewrite it because it's just over 1, okay? But just remember that it's a positive or a negative for each of those. You just have to start going through there, kind of trial and error, and figure out which ones would work. If you did -1 for synthetic division, you would have 1, 2, -11, 8, -60. Bring down your 1 and you have -1. Bring down your 1, -1, -12, positive 12, 20, -20, -80. All right, that is not going to work. Okay, that's a bad one. So we've tried +1. That was -1. Now we could try +1. We have a 1, a 2, -11, 8, -60 still. So we have 1 times 1 is 1. This makes it 3, 3, -8, -8, 0, 0, -60. All right, neither one of your 1s work, so this is gone. So then you would do it with your 2. And it's still 1, 2, -11, 8, -60. Bring down your 1, 2, 4, 8, -3, -6, 2, 4, -56. Not going to work. Then you would try the -2. 1, 2, -11, 8, -60. Bring down your 1. You have a -2, 0, 0, -11, 22, 30, -60, and negative 120. It nearly worked, but no. So then you would try your 3. You have your 1, 2, negative 11, 8, negative 60. Bring down your 1, you've got 3, 5, 15, 4, 12, 20, 60, 0. Hey, we finally found one. So then you would try your negative 3, you would try your negative 4, you would try your 5, you've got to try all of those. And any of the ones that work, okay, keep in mind there should be 4 zeros total. So keep that in mind. And if you were to do all of those, you would discover that your zeros are 3 and negative 5 are your 2 rational zeros. You also have an imaginary one, plus or minus 2i. So it's long, it's drawn out, but what you've got to do is test every one of them that you have listed here. And if it gives you a 0 for the remainder, then it works and you're going to list it as part of your answer. If it doesn't, then it wasn't wasted effort, but it ruled it out. It does not count. All right, that's all of the notes. You're ready for your assignment.